Since Optimus's initial announcement in 2021, the tech world has been closely following Tesla's every step toward building a functional humanoid robot. Elon Musk surprised everyone by announcing that Tesla, known for its electric cars, was entering the robotics field with a bold proposal. The project seemed, at first glance, like something out of science fiction, a human-like robot designed to perform tasks that were tedious or dangerous for humans. Many critics doubted the project's viability, arguing that humanoid robots are complex, expensive, and of little practical use. However, what seemed like a mere marketing ploy soon became a real, fast-paced initiative. The first Optimus prototype, still in its early stages, appeared with limited movement, but it clearly demonstrated the direction Tesla intended to take. The company invested heavily in hardware and software development, leveraging its expertise in artificial intelligence, sensors, and actuators gained from autonomous vehicles. This technological foundation allowed it to accelerate progress on the robot's design. In late 2023, Tesla unveiled the Optimus Gen 2. Much more refined than the initial prototype, the new model featured a significant leap in mobility, dexterity, and learning ability. Its joints were smoother, and its movements more natural. One of the Gen 2's greatest strengths was its ability to perform tasks like folding laundry or manipulating objects with precision. This marked a new era in humanoid robotics, demonstrating that the robot could interact efficiently with domestic and industrial environments. Manual dexterity was one of the areas Tesla's engineering team emphasized most. The goal was to build robotic hands as close to human complexity as possible, with multiple degrees of freedom for delicate movements. With the announcement of the Optimus Gen 3, scheduled for release soon, anticipation has increased even further. The new version is expected to come equipped with hands with 22 degrees of freedom, a crucial advancement for tasks requiring refined control and tactile sensitivity. Tesla believes this level of control will allow the robot to perform actions such as opening jars, connecting cables, performing delicate assemblies, or even playing musical instruments, something unthinkable for most current robots. In addition to physical improvements, Optimus Gen 3 is expected to incorporate significant advances in artificial intelligence. Its observational learning system promises to be a game-changer in robot training. The idea is simple yet powerful. The robot can learn new tasks by watching videos of humans performing them. This eliminates the need for manual programming and direct training, dramatically accelerating the robot's adaptation to new functions. This type of learning is inspired by the way humans observe and imitate. By applying this to a robot, Tesla is paving the way for a new era of versatile robots capable of continuous learning without technical intervention. In an industrial environment, this means that an Optimus can be deployed on a production line and within a few days be able to perform complex tasks simply by watching training videos. In domestic life, the impact could be even more transformative. Imagine a robot that learns to wash dishes, organize closets, cook, or even care for the elderly simply by watching tutorials. The potential is immense. Tesla plans to initially use Optimus in its own factories, testing it on real-world production and logistics tasks. This will allow it to validate the robot's effectiveness in challenging environments and fine-tune its performance based on real-world data. This will ensure that the company can ensure that when the robot is made available to the public, it will already be adapted to real-world requirements. This strategy also helps reduce the risk of malfunctions or large-scale failures. One of the biggest challenges facing humanoid robotics is mobility. Although Optimus Gen 2 can already walk reasonably well, its speed is still limited, falling short of the desired target of 5 mph, about 8 km/h, which is close to human walking pace. Elon Musk has acknowledged that this is one of the most challenging areas to solve. Balancing agility, motor coordination, and stability is one of the biggest obstacles in building functional bipedal robots. Coordination between sensors, motors, and algorithms is crucial to prevent falls, trips, or artificial movements that compromise the robot's efficiency. Each improvement in this area brings Optimus closer to wider social acceptance. Another relevant factor is safety. Musk and his team recognize that integrating artificial intelligence into a robot's physical body can pose risks. Therefore, Tesla's business model relies heavily on leasing. With leasing, Tesla retains control of the software, allowing it to stop, update, or limit the robot's use at any time. This provides an extra layer of security against abuse or misuse of the technology. Additionally, leasing makes access to the robot more affordable for businesses, reducing the upfront cost and allowing Optimus to be used as a service, similar to a software subscription model. The economic aspect is one of the project's pillars. According to estimates, an Optimus robot can work up to 7,000 hours per year, with an operational savings of up to $83,000 per unit. A return on investment can occur in less than 4 years. This is particularly attractive for industries facing labor shortages or high operating costs. In sectors such as logistics, assembly, agriculture, and manufacturing, Optimus could be a game-changing solution. Elon Musk has stated that Tesla could become a $25 trillion company thanks to the revolution brought about by Optimus. He believes humanoid robots will represent a new industrial revolution, but Musk's vision goes beyond profit. He believes that robots like Optimus will allow humans to focus on more creative, artistic, or intellectual pursuits, leaving repetitive tasks to machines. In this scenario, robots would be seen as personal assistants, helping in everyday life without eliminating jobs, but transforming the way society works and lives. Automation, when applied well, has the potential to free up people's time and energy, improving their quality of life. Optimus could be the first step toward this new reality. However, there's still a long way to go before these robots become a commonplace in homes and offices. The technical, regulatory, and social challenges remain significant. Public acceptance will also be a determining factor. Humanoid robots still arouse fear and distrust in many people, especially when it comes to advanced AI operating autonomously. Tesla will need to work not only on the technology, but also on communication and the ethics of using these robots. Dialogue with governments, regulators, and society at large will be essential to ensure safe implementation. Transparency in development processes and the inclusion of security mechanisms are essential to gaining public trust. Another important aspect will be Optimus's modularity and upgradability. As technology evolves rapidly, it's essential that robots can be easily updated without the need for complete replacement. Tesla plans to implement software updates, just as it does with its vehicles. This will allow a robot in operation today to remain functional and modern for many years. Continuous learning is also a strategic differentiator. As the robot learns over time and from different contexts, it becomes more efficient, adaptable, and valuable. This accumulation of knowledge can be shared between robots, creating a kind of collective mind that further accelerates the advancement of Optimus's intelligence. This concept is very reminiscent of the neural databases used by virtual assistants and self-driving cars, but with a concrete physical application in the real world. If this model is successful, Optimus will be able to not only perform tasks, but also anticipate needs, collaborate with humans, and even act proactively. This is where the revolutionary potential of this technology comes in. A robot that not only obeys commands, but also understands its environment, learns from it, and interacts intelligently represents a new frontier in robotics. Tesla isn't alone in this race. Other companies, such as Boston Dynamics, Agility Robotics, and Figure, are also developing humanoid robots. But none possess Tesla's combination of financial resources, AI expertise, and industrial infrastructure. This puts Elon Musk's company in a prime position to lead the market when humanoid robots become commercially viable. If all goes as planned, Optimus could, within a few years, be as common as a smartphone or a robotic vacuum cleaner in our homes and businesses. The path is challenging, but the first steps are already being taken. The world is closely watching Tesla's progress in this area, aware that we are facing an unprecedented transformation. As Optimus makes its way through Tesla's labs and factories, technology experts are widely discussing the impact this robot could have on the global job market. Automation has been replacing manual tasks for decades, but a multifunctional humanoid robot takes this debate to a new level. Unlike traditional machines, which are designed for specific functions, Optimus promises to be a universal work platform. This means it can be reprogrammed or adapted for different tasks over time, offering longevity and flexibility uncommon in the industry. This versatility could profoundly transform sectors such as logistics, construction, healthcare, hospitality, and personal services. The same robot that works in a warehouse during the day could theoretically be reprogrammed to act as a home caretaker at night. However, this promise of flexibility also requires the AI system to be highly reliable. It's not enough to simply move objects or walk. The robot will need to make contextual decisions, navigate unpredictable environments, and accurately understand human instructions. Therefore, Tesla is investing heavily in the development of a sophisticated digital brain capable of integrating computer vision, natural language interpretation, reinforcement learning, and real-time decision-making. The use of advanced neural networks and continuous learning based on large volumes of data will be essential to ensure that Optimus can handle real-world complexities safely and efficiently. This focus on contextual intelligence is what differentiates Optimus from traditional industrial robots, which operate in controlled environments with repetitive tasks. Here, the challenge is to create a robot that functions in an unpredictable world full of human nuances. Beyond technical issues, humanoid robotics also faces ethical dilemmas. How can we ensure that the data collected by the robot isn't used for malicious purposes? How can we prevent mass surveillance disguised as home automation? These concerns will be central to regulating this new technology. Many experts advocate the creation of international protocols that guarantee transparency and user rights in environments where intelligent robots are present. Tesla, for its part, promises transparency and cloud-based control mechanisms where the robot's behavior can be monitored, updated, and limited remotely if necessary. Still, public trust will depend on concrete evidence and rigorous testing. Optimus's advancement also raises philosophical questions. At what point does a robot cease to be merely a tool and become a presence with an active influence on human life? Are we prepared to share our personal space with machines that mimic our gestures and voices? This fine line between convenience and discomfort will be a cultural challenge, especially in more conservative societies or those with a history of rejecting automation. Tesla will have to balance innovation with empathy. One possible solution would be to allow robots to be customized, from appearance to behavior and voice. This could create a more natural relationship between humans and machines, reducing the awkwardness many feel toward humanoid robots. Aesthetics will also play a key role. A robot that looks too much like a human could trigger the so-called uncanny valley, the valley of uncanny feeling, where imperfect resemblance causes repulsion. Tesla will need to strike a balance between form and function. So far, Optimus's design has remained functional and minimalist, avoiding detailed human features. This helps focus on the robot's usefulness, not on trying to simulate a living being, which could lead to confusion or unrealistic expectations. Another factor that could help Optimus gain acceptance is its ability to collaborate with humans rather than replace them. Collaborative robots, or cobots, are already present in factories and offices, providing assistance without directly displacing jobs. Optimus could expand on this concept, acting as an assistant in heavy, repetitive, or dangerous physical tasks, while humans focus on creative, strategic, or interpersonal aspects of the work. This model of human-machine collaboration can be a bridge to the future, where automation increases productivity without generating mass unemployment, as long as public policies and education are aligned with this transition. Education, in fact, will be key in the new era of robotics. Professions related to programming, maintenance, supervision, and teaching robots are expected to grow significantly in the coming years. Furthermore, children who now grow up alongside voice assistants, artificial intelligence, and wearable technology will have a much more natural relationship with robots like Optimus.